Okay, welcome back to the CloudCalc how-to videos. This one's going to be talking about how to set up CloudCalc. And it's basically the sort of things you want to do before you start building a model or before you start doing any real project work. You're going to need to go in and set up or define the way you want the program to work, basically the way that you are going to work. It's going to involve several things. Partly it's the configuration where you go in and say, how CloudCalc should operate under certain circumstances, what units you want to use, what code you want to default to, etc. Then there's a units utility itself, where you can design your own type. You can look at the various units that come shipped with the product, or you can design your own custom set of units. The catalog is where you'll set up the type of pipe sizes that you typically work with, the type of materials that you typically work with, so that you can put them in your drop list. We don't want to ship the product so that you have a drop list with 200 different pipe sizes or 800 different materials in it. So we allow you to select from all of the data that we have online to pick a working subset that's going to most commonly fit what you do. So let's talk about this. The first step after going through the video one was introduction to how the product works, or what it looks like, what the menus do. Second one is probably the first step you want to do. You're going to come in and set up the way you're going to run these. So let's pick CloudCalc configuration, and we'll see a number of things that you can set. This is a deformed shape display scale, and when you get displacement shown on the screen, for example, displaced shape, it's a scale. So this will show displacements so they're easier to see at 5 times their actual value. You can change that if you want to magnify those, make that 50 or some other value. Typically a 5 is a good place to start. Next is your default node increment. When we come up and you start a new model, we'll start with 5 or 10 or whatever you have to set this to as the from node, and then add that increment to that. So we'll start 10 to 20. If you can change that to anything you want. Typical values are 5 or 10, but you can make it 1 or 100 or something like that. Change this. Default units. When you start a new job, what set of units will be in play? You can generally, for an existing job or as you go along, you can change the units. You can convert to different units. We'll see how to do that in a minute. But initially, we ship the product, or the product set up to work with 5 different types of units, 2 English, 3 metric. We can go into the units utility and see what's involved or what the different types are. You can also create your own custom unit set, but here you'd select the ones that you want in general for your jobs to start with when you create a new job. Default piping code is either going to be B31.1 or B31.3. At the moment, B31.1 is not operable, so we'll use B31.3 here. B31.1 ought to be very soon. Also, auto-generate bend nodes. When we create a bend, we have the option to automatically insert intermediate nodes, and we can tell it you can automatically insert up to 3. So this is at what angle do we want to put it? This is angle 0. This is M. It means midpoint of the bend. We can add a third one if we wanted a 60-degree bend location or something like that. We could add that as well. So this will automatically create 2 intermediate nodes whenever we create a bend. This option here, activate auto break. It means that whenever you cross 2 pipes in a system, if we have this turned on, it will automatically break those pipes and reconnect them at a 6 degrees of freedom with a node in between. If you do not turn this on, they'll basically cross virtually in space, but they will not have any interaction as element to element. Generally, this is the recommendation that we suggest. It'll make it much easier to build your models. And then your default piping catalog that you're going to work with. This is not so important. It just means that when you go into the piping catalog utility, as we see later, it will initially have the box checked either your imperial pipe size or metric pipe size, or both. You could add both if you wish. Okay, so you'd set that up, and every time you come in to CloudCalc, your program will be set to work that way. If you create a new model, your model will be set to take those configuration parameters. Next thing you might want to look at is, I mentioned, units. We can go into units and see what we have to choose from. Whenever you initially go in, it'll show the current units. It's the model that you're working on right now. What units are you dealing with? And it'll say for force, for length, for displacements, for moment in, moment out, etc. The name of the unit and the factor. Basically multiply, if you multiply the English standard unit by this factor, you'll get this many of this. So for example, displacement's millimeter 25.4, because you have 25.4 millimeters to the inch, which happens to be this English standard. If you're curious what is the English standard, you can look at these other sets of units. English standard, as far as CloudCalc is concerned, is English 1. So the force is pounds, length is inches, displacement is inches, etc. Moments in is inch pounds, and so these factors are all 1. Other units that we have to choose from, we've got English 2, which basically is similar to English 1 except uses feet for length. Metric 1, which is a millimeter and megapascal and newtons per meter squared, newtons per millimeter set of units. You look at metric 2, then we've got length in meters, etc., loads in kilogram force. Metric 3 is millimeters and, length in meters and kilonewtons for forces and things like that. If you don't like any of these, you can create a new set of units. You pick an existing set that best reflects or that you want to use as your starting point. We can then say, give me a new one. Let's give it a name, mixed, for example. We're going to use some mixed English and metric. Come in here. We now have a choice we can select from our drop list. So the force, we could use any of these things. We might want to say kilonewtons. Moment in, we want to use foot kips, uniform load, etc. We might want to use newtons per meter. Mass would be slugs, looks good. Temperature, centigrade. And then when you save that, you now have a set of units existing that you can use in the future. For example, if you come in and change your configuration, you might always want to default to that mixed unit set or that custom unit set that you made. The other thing you can do is anytime you come into units, you can pick something from your list, for example, mixed, and we can convert the existing model that you have here. So now when we look at this, you see a bit of a mixed bag. So your lengths are in inches. What else do we have? Forces, concentrated loads. These are in kilonewtons and things like that. So we did a conversion here and converted it easily to a new set of units. So we did the undo and it came back, switched back to metric the way it was. So you might want to think about what set of units you want. Typically we recommend English 1, metric 1, or your own custom set of units, or maybe one of the other ones we have, and set that up and then go into configuration and set that as your standard going forward. The next thing is the pipe types and the material types. When you first log on to CloudCalc, you'll see that we provided you with basically 6 different pipe sizes: 4-inch standard, 6-inch standard, 8-inch standard, 8-inch extra strong, etc., 10 and 12. Just a few to get started. We also have a pipe custom. So if there's one that's not there and you click this, you can type in the pipe outer diameter and the pipe wall thickness. Okay, or if you go standard, it will know the sizes. You may, if you're curious about the properties of these particular items, you can click this property button here, and it'll show you the outer diameter area, wall thickness, section modulus, etc., and moment of inertia. Now, if you want to add to this, if you know on your project or in your model you're going to need quite a few other types of pipes, you can go in and work with your catalog here. So we can say catalog, pipe sizes. Now we can say what do we want to extract from the database. The database has imperial sizes. metric sizes, it has standard steel schedules, it has stainless steel schedules. You may not want all that. If you want all that, that's fine. You can just highlight all this. But if you want just a subset of what we have online, you can bring this in, click here, and you get a list of all the pipes from our database. So if we need, for example, we may need a 16-inch pipe, we know that we're going to be working with. We can do 16, select here, look from my drop list, maybe I want 16-inch standard, look at my properties here. That looks like the pipe I want. I can add that to local here, and it's now going to be part of my drop list. I may need a 20-inch pipe, 20-inch standard. Add that to the local. A 24. 24-inch pipe, and say a 36-inch pipe. So I can go ahead and add these. So these will now be part of my drop list that I can choose from. You can do this on the fly, or we recommend that you may want to do it in advance, but if you get to a point in your modeling and you find you don't have a pipe in the drop list that you need, you can do it on the fly, no problem there. And one thing you might want to do is change the order of that list, which is very easy to do. Simply come in here and let's say we want to put pipe custom at the end. We can simply move this down, and now it should be in the order that we want. And when you come back into your modeling, you've got this thing built the way you want to go forward. And again, if you've forgotten something, you can always change it on the fly. It works the same way with materials. We provide a number to start, A53B, 106B, a number of others, and then you can go ahead and add to this if you wish. So we can go catalog, materials. We bring in the various materials from the data base. If you're curious about these properties, you can take a look here. It's got the standard modules of elasticity, Poisson's ratio, yield stress, etc. And it's got the temperature-related values as well, allowable stress versus temperature, coefficient of thermal expansion versus temperature, modulus of elasticity versus temperature. And we can go through and find a particular item that we need, A182, for example, and it's now added to the list. So when you're modeling, we can easily grab that. And again, that can be done on the fly while you're building as well. Okay, so that's basically the only setup you've had to do before you get started. The units, the configuration, set up your local member and material catalogs that you're going to be working with. And at this point, good luck. Thank you for helping out in the beta. And the next video, we will go into modeling. We'll model something and see how that works. So thank you, and goodbye till next time.